Okay, so in this situation, we're checking if these meters are defective or not. So that's a yes or no question. So that tells us it's a proportion. Okay, so we have to find the sample proportion ourselves. So out of 320 total meters, 12 are defective. Okay, so here's our sample proportion. And then now we can apply the sample proportion confidence interval formula. Okay, we want 95% confidence, so we're familiar with our number 1.96. Okay, and then over n, the standard sample size. Okay, so calculating the margin of error. Okay, so it looks like margin of error is about 0.0208. Okay, so adding and subtracting that from our sample proportion. Okay, so if we wanted this in percent form, we'd say, or we could just write it out. Okay, so what do these numbers represent? We're measuring how many are defective. Okay, so I'll just convert them back to percent form. So this would be 1.67%, and this would be 5.83%. Okay, problem 6. Okay, so can the 4-year-olds provide the first and last name of one parent or guardian? So again, yes, no question, this is a proportion. Okay, so this time they gave us the sample proportion, so we know p hat is going to be 0.547. Okay, and then here's our sample size n. Okay, but then what is what we called z star? What is it for a 99% confidence interval? So we had most often used a 95% confidence interval. So how did you do 99%? So a 99% confidence interval means you want the middle 99%, which means that there's only 0.01 on the outsides, but since it's symmetric, each individual tail is 0.05, 0.005, excuse me. Okay, so we want this z value. So to the left of this is so the total area is 0.99 plus 0.005. So if I just glue those two sides together, Okay, so sorry, this 5 should go right here, right? 0.99 plus 0.005, yeah. Okay, so I'm looking for the z value, which corresponds to an area of 0.995 on the left. Okay, so 0.995. Okay, so these two are equally far apart. So it's about 2.57, or, sorry, you can't see that. Right, so this row corresponds to 2.57. Or it could be a little bit above that. So we'll just go with 2.57. Okay, so that's our z star. So now we have all the information we need for the confidence interval. We have our sample proportion plus or minus z star times the radical of sample proportion times 1 minus sample proportion, all divided by the sample size. Okay, so here's our margin of error. And now let's go ahead and actually add and subtract it. Okay, so we can state with 99% confidence the true proportion of 4-year-olds who can say their name or the name of their parent or guardian is between, so again in percent form this would be 48.95% and 60.45%. Okay, so this tells us it's going to be population mean, but even if they didn't, we see that the data is numerical, right? What is the price of 1 gallon of gasoline? So the data is going to be a number. Okay, so we are asked for a 95% confidence interval, the number we're used to. So we could just do the sample mean plus or minus, because it's 95% confidence interval, we know that z star is 1.96. Okay, times the population standard deviation divided by the square root of the sample size. Okay, so let's find the margin of error. So about 0.0268, and then the actual confidence interval. So with 95% confidence, the true mean of one price of gasoline is between so normally we don't really go past 2 decimal points for money, but gas stations do charge fractions of a penny, so why not? Okay, so again, this is sample mean because the data is numerical. It's the amount of time, which is a number of minutes. Okay, so this time we're looking for a 90% confidence interval. So that means, okay, so middle 90%. So that leaves 10% on either, 10% combined on both sides. So you split that in half to get 0.05 in each tail. Okay, so that means that what we're going to look up on the z table is 0.95. Okay, so 0.95. Okay, so it's halfway between these, right? 1.64 or 1.65. I mean, so we could just go halfway between them if we wanted. Or I'll just go with 1.64. Okay, so sample mean plus or minus z star times the population standard deviation divided by the square root of the sample size, right, 149 travelers. Okay, so it looks like we have this margin of error. And now we add and subtract that from the sample mean. Okay, with 90% confidence, the true mean amount of time it takes passengers to clear security is between 27.4401 and 29.1599 minutes. Okay, so here we're looking about the amount of time that phones can play a video before running out of power. So that's numerical, the number of hours. Okay, so we're looking for a 99% confidence interval again. So I'll just reuse the number from before. Right, so 0.99 in the middle, you add on the tail. The area to the left of your desired z-score is 0.995, so we're going to use a z-value of 2.57. Times population standard deviation divided by square root of the sample size. Okay, there's the margin of error, and now we'll add and subtract it from the sample mean. so explaining this with 99% confidence, the true mean, we'll just say battery life, lies between 12.2646 and 13.1354 minutes. Okay, so we're looking for 90% confidence interval again. So same thing as problem 8. 90% in the middle means there's a tail of 0.05 on the left. So we look up 0.95 on our z-table, and then we get the appropriate z-score. So 0.95, again, was halfway between, so we just used 1.64. Okay, sample mean 107.9 times sigma divided by square root of n. Okay, so here's our margin of error.